Drop a cup. It shatters. Shards scatter across the floor. You've never seen the reverse happen, never seen fragments spontaneously leap up and reassemble into a whole cup. Why not? Why does time only go forward? Why can't broken things unbreak themselves? Einstein explained that time is a dimension, that it bends near massive objects, that it slows down at high speeds, that it even stops at the speed of light. But he never explained why time has a direction. Why is the future different from the past? We say time flows forward, but that's just describing what happens. That's not an explanation. Hawking found the real answer, and it's not about clocks or relativity. The reason has nothing to do with physics, as Einstein understood it. It's about what the universe is becoming. Einstein's equations are beautiful. Time is the fourth dimension. Space and time curve together around mass. Clocks run slower in gravity wells, slower at high speeds. The mathematics work perfectly. But here's what's curious. The equations don't care which direction time goes. You can run them forward or backward, and they work equally well. Past and future are symmetric in relativity. Einstein bent time, stretched it, compressed it, wove it together with space. But he never asked why it has an arrow. Why does it point from past to future and never the reverse? That asymmetry isn't in his equations. So where does it come from? Look at the shattered cup again. Every fundamental law of physics is reversible at the microscopic level. Newton's laws of motion work perfectly backward. If you film billiard balls colliding and play the video in reverse, you can't tell. The physics looks identical. Quantum mechanics is time symmetric. The Schrödinger equation runs forward or backward equally well. Yet we never see certain things in reverse. Smoke doesn't flow back into a chimney and turn into wood. Eggs don't unscramble themselves. Water doesn't spontaneously flow uphill. Heat doesn't flow from cold objects to hot ones. The common answer is entropy always increases. That's the second law of thermodynamics. But that's just another label. What is entropy, and why does it increase? Let's be precise. Entropy is the number of ways the microscopic parts of a system can be arranged while still looking the same macroscopically. Take a room full of air molecules. Low entropy means there are very few arrangements, like all the molecules huddled in one corner. High entropy means there are many, many arrangements, molecules spread throughout the entire room. It's simple probability. There are vastly more ways for molecules to be spread out than concentrated. Think of a deck of cards. There are 52 factorial ways to arrange the cards. That's about 8 times 10 to the 67th, a number so large it's meaningless. But there's only one perfect order. Say, ace through king of each suit in sequence. Shuffle the deck randomly. You will never ever get back to that perfect sequence. Not because of a law, because of overwhelming probability. The disordered states outnumber the ordered ones by such a staggering margin that ordered arrangements effectively never appear. And that's entropy. But wait, this raises a terrifying question. If entropy always increases, trace backward in time. The universe gets more and more ordered as you go back. More and more improbable. At the Big Bang, 13.8 billion years ago, the universe was in an extremely low entropy state, one of the most special, unlikely configurations possible. Why? Probability says it should have started in a random, high entropy state. That's vastly more likely. Instead, it started in this incredibly special arrangement. This is what Einstein missed. He showed us how time bends. He never asked why it has a direction. The direction comes from that initial condition. By the 1960s, physicists just accepted it. The initial conditions were special, they said, and moved on. Hawking asked, why were they special? And more importantly, where does this lead? Here's where it gets terrifying. Every irreversible process you've ever witnessed, the cup shattering, a star burning, a thought forming in your brain, every single one increases the total entropy of the universe. The universe is moving inexorably toward maximum disorder, toward what's called heat death, an eventual state where nothing can happen anymore, all energy spread uniformly, no temperature differences anywhere, no gradients. And without gradients, no work can be done, no stars can burn, no life can exist, no thoughts can form, no time can pass. We exist only because we're riding the entropy wave from the ordered past toward the disordered future. We're surfing the gradient between the Big Bang and heat death. Actually, it's worse than that, because time itself depends on this process. Hawking saw something others missed. There are three arrows of time. The thermodynamic arrow, entropy, increases. The psychological arrow, we remember the past, not the future. And the cosmological arrow, the universe expands. All three point in the same direction. That's not a coincidence. Your memory works because brain states become more disordered. Recording a memory increases entropy in your neurons. The physical act of storing information requires increasing disorder somewhere. You can't remember the future because that would require decreasing entropy, which doesn't happen spontaneously. You might think consciousness transcends physics. It doesn't. Your thoughts, your memories, your sense of self, all riding entropy's arrow. This has been measured. The act of erasing one bit of information in a computer generates heat. That's entropy increase. Landauer's principle, discovered in 1961. The minimum entropy cost of erasing information is K times the natural log of 2, where K is Boltzmann's constant. Your brain does exactly the same thing when forming and revising memories. Every thought you have increases the entropy of the universe, which means something disturbing about what we are. You're an entropy machine. Every moment you exist, you increase the universe's disorder. You eat food, highly ordered molecules. You metabolize them, convert their chemical energy to motion and thought, and produce heat and waste. Disordered. Your very existence makes the universe more random. Let us be honest about this. You are a local decrease in entropy, but you're powered by a much larger increase elsewhere. The sun burns hydrogen into helium, loses order, radiates energy into space. That energy reaches Earth. Plants capture it. You eat plants, or eat animals that ate plants. That solar energy runs your body, runs your brain, runs every thought you think. The net result, the universe becomes more disordered than it was before. The sun loses more order than you gain, always. But Hawking saw something even stranger when he looked at black holes. A black hole appears to be perfect. Order, matter crushed to a point, or at least to the event horizon. Seems like it should have zero entropy. Here's the problem. Take a hot cup of coffee, full of thermal entropy, molecules jiggling randomly. Throw it into a black hole. The coffee disappears beyond the event horizon. Where did all that thermal entropy go? It can't just disappear. That would violate thermodynamics. In 1972, Jacob Bekenstein suggested that black holes must have entropy. Hawking initially disagreed. The idea seemed wrong. Then Hawking did the calculation and discovered Bekenstein was right. Not only do black holes have entropy, they have enormous entropy, proportional to the surface area of the event horizon. A black hole with the mass of our sun has more entropy than the sun itself, more than anything else that size in the universe. And here's the terrifying part. Black holes aren't perfectly black. They radiate. Hawking discovered this in 1974. Quantum effects at the event horizon cause black holes to emit particles. They have a temperature. It's inversely proportional to their mass. A small black hole is hot and radiates quickly. A large black hole is cold and radiates slowly. But all black holes, every single one, eventually evaporate completely. The time scales are staggering. A black hole with the mass of the sun takes 10 to the 67th years to evaporate. The universe is currently about 10 to the 10th years old, 13.8 billion years. We're talking timescales that make the current age of the universe look like an eye blink, a supermassive black hole at the center of a galaxy. 10 to the 100th years, maybe longer. Actually, it's not just that they'll evaporate eventually. When a black hole evaporates completely, something strange happens to the information inside. The coffee you threw in, every detail about those molecules, their positions, their momenta, all that information seems to disappear when the black hole evaporates. The Hawking radiation coming out is thermal, random. It doesn't carry the information about what fell in. This created the black hole information paradox. Does quantum information get destroyed? That would violate quantum mechanics, which says information is always preserved. 50 years later, it's still being argued. Some think the information escapes somehow in the radiation. Some think it's stored on the event horizon. Some think the information truly is lost, and quantum mechanics needs revision. But zoom out further. Look at the really far future. 10 to the 100th years from now, or longer, all the black holes have evaporated. Every star burned out billions of years earlier. If protons decay, all matter has dissolved into radiation. The universe is a thin soup of photons and elementary particles. Temperature approaches absolute zero. Maximum entropy has been reached. Nothing can happen anymore. No energy gradients exist, no complexity, no structures, no life, no thought. And here's what should disturb you. Time itself may stop. If entropy stops increasing, the thermodynamic arrow disappears. If the universe stops expanding, or if it accelerates infinitely into void, the cosmological arrow disappears. Without change, without any difference between one state and the next, what is time? Does it even exist? Circle back to the cup. It shatters because the universe started in an impossibly improbable, low-entropy state 13.8 billion years ago. We remember it whole because our brains write entropy's arrow forward. We can't unsee it shatter because that would require time running backward, entropy decreasing spontaneously. And time only runs forward because the universe is dying. The terrifying truth Hawking uncovered. Your consciousness, your memory, your sense of past and future, all of it is a temporary phenomenon. We exist only in this brief window between the Big Bang's order and heat death's disorder. Einstein showed us time is relative, flexible, geometric. It bends. It stretches. It dilates. Hawking showed us something else. Time is mortal. Time itself will end, not in billions of years. In 10 to the 100th years, maybe much longer. But it will end. The arrow will stop. Nothing will change. And without change, there is no time. Next question. What happens to the information that falls into a black hole? Does it truly disappear? Is quantum mechanics wrong? Or is there something we don't understand about the event horizon? That's still being argued. Brilliant people disagree. I've got to stop somewhere.